We're going to be looking at the boxes in the periodic table to get information about each atom's nucleus, its subatomic particles, its number of electrons, etc. In the middle of each box will be the element symbol, which you've already learned. There are two other numbers included in the box which are very important to us. One is the atomic number. The other is the atomic mass. They're not always put in the same order. Sometimes the atomic number is on the top, or in the corner, or maybe even in the bottom, depending on who published the periodic table and what they thought looked best. But the important part is to know how to figure out which is which and what they tell you. In general, the larger of the two numbers, that's usually to a decimal place, is going to be the atomic mass, because it's an average of all the possible combinations within the nucleus of the protons and the neutrons. Whereas the atomic number will be the smaller of these two numbers, only tells the number of protons. And since atoms are electrically neutral, the number of positive protons is equal to the number of negatively charged electrons in the outer shells, so that atomic number will also tell you the number of electrons. The atomic number is also the way that we sort the elements on the periodic table. So the 8th element on the periodic table is oxygen. This is a form of nuclide notation. It tells us the symbol. In this case, this would be the element. That's right, sodium. There are two numbers. There's a smaller number, 11, and a larger number, 23. The larger number refers to the mass of the atom. The mass is made up of the protons plus the neutrons. These exist together in the nucleus of the atom, and the mass is the combination of those two particles. The atomic number, the smaller of those two, refers only to the protons. But as we said, since atoms are electrically neutral, it would also indicate the number of electrons. But electrons are teeny tiny. They don't have enough mass to even matter, so that is not included in the mass number. Now, this particular symbol includes a charge. We'll come back to that in a later lesson. Atoms from the same type of element that have different numbers of neutrons are referred to as isotopes. These two are examples of isotopes of the element oxygen. The symbol for oxygen is O. As you can see, both have 8 protons in the nucleus. In one example, the nucleus also contains 8 neutrons, so that the mass of this atom of oxygen would be 16. Its isotope, its cousin, also having 8 protons, has 10 neutrons in the nucleus. Since protons and neutrons have about the same mass, we say that they have a mass of 1 atomic mass unit. We add those two together, and the mass of this isotope, 10 plus 8, would be 18 atomic mass units. It's what we refer to as a heavier element. Because there are 8 protons in oxygen, we can anticipate that there will be 8 electrons as well. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. In both isotopes of oxygen, there are 8 electrons in addition to the 8 protons. The difference are the numbers of neutrons. Here's another example. This is the element carbon. As you can see, carbon-12 contains 6 protons, 6 neutrons, both located in the nucleus, the neutrons being the blue dots and the protons being the red dots, and also 6 electrons. Those are the green dots on the outer shell. But carbon-13, while it does have 6 of the red dot protons and has 6 of the green dot electrons, has a different number of neutrons. It, in fact, has 7 neutrons. And then finally, the third example, carbon-14, we again have our 6 protons and the same 6 electrons. And how many neutrons do you suppose it has in its nucleus? That's right, there are 8 neutrons in the nucleus. So the only difference in these elements is the total mass, because the number of neutrons varies. This designation, after the name carbon, carbon-12, carbon-13, carbon-14, refers to the mass of each isotope. You can see that 6 plus 6 is 12. 6 plus 7 is 13. 6 plus 8 is 14. We'll be calculating some of these nuclides in class.